Okay, this is lesson 10.1 on exponents. A power is defined as a product of repeated factors. The base of a power is the common factor, and the exponent of a power indicates the number of times the base is used as a factor. So in this diagram, you can see all the parts. When you have the quantity 1/2 in parentheses to the 5th power, the whole thing is called the power. The base is the repeated factor, or in this case the 1/2. The exponent of 5 tells you that 1/2 is used as a factor 5 times. So example 1, write each product using exponents. Since the repeated factor is -7 and it is repeated 3 times, you would put -7 in parentheses with an exponent of 3. For part B, you have pi times r times r times r. Pi is a factor 2 times, r is a factor 3 times, so pi squared r cubed. Note also that multiplication is commutative. If you had r times pi times r times pi times r, you still have pi as a factor 2 times, r as a factor 3 times, and you still have the same solution. So let's try some of these. We want to write the product using exponents. Since 1/4 is the factor and it is repeated 5 times, use parentheses so that you can show the whole fraction 1/4 as the base. If you neglect to put the parentheses, it could inaccurately look like the numerator is the only one raised to the exponent. For number 2, you have a decimal, 0.3, that is repeated 4 times, and a factor of x that is repeated 2 times. So again, use parentheses to show that the decimal 0.3 is a repeated factor 4 times, and x is repeated 2 times. There is no need to put the multiplication dot multiplication between those two. When you're evaluating expressions, this time you want to find the value for the power. So for part A, we know that the -2 is the base. So that's something you really need to pay close attention to, because you can see in A and B there's some similarities. The only difference is the parentheses. So when the -2 is inside parentheses and the exponent of 4 is outside, we know that the base is repeated 4 times, and that is -2. So -2 times -2 times -2 times -2 is a positive 16. When you have a negative factor, and in this case it's the same negative number, and the number of times it's a factor is even, so the negative number is a factor an even number of times because of the 4, we know that we'll have a positive outcome. Again, if the exponent had been an odd number, we know that we would be taking, like say if it was to the 5th power, that 16 times one more factor of -2, that odd number would give us a negative outcome. So right now we have a positive outcome because we had an even exponent. In part B, we have the opposite of 2 to the 4th power. So the repeated factor is the base of 2. It is not negative, right? So we want the opposite of 2 to the 4th power. So 2 to the 4th is 16. The opposite of that is -16. When you use order of operations, you want to evaluate the powers after you do parentheses. So it would be the same time you would be doing any kind of roots or cube roots, so forth. So 3 plus 2 times 3 to the 4th power. We have to evaluate the power first. So 3 is a repeated factor 4 times, is 81. Then do the multiplication, so 3 plus 2 times 81, multiply the 2 times the 81, then add. In part B, 3 cubed minus 8 squared divided by 2 is going to be equal to 27 minus 64 divided by 2. You must divide before you subtract. So we'll try some of these. So in this Evaluating the expression in 3, negative 5 to the 4th, the base is 5, so we want the opposite of that. So to show our work, we could put the negative on the outside of parentheses and repeat the factor, which is a positive 5, 4 times. Going left to right, 5 times 5 is 25, times another 5 is 125, times another 5 is 625, so the answer is a negative 625. In this next one, the base is a negative 1/6, so we know that the repeated factor is negative 1/6. And when we multiply, there's no need to enter any fractions on our calculator or anything because we can go left to right. So we could do these two first. So we have a negative times a negative, which will give a positive value. 1 times 1, multiplying the numerators, over 6 times 6, which is the denominator. Then that is multiplied by one more factor of 1 over 6. Positive times a negative will give a negative. Here's another concept where the exponent is odd. We are multiplying negative factors, so there are 3 negative factors. We know that we'll have a negative result. So 1 times 1, again, numerator stays as 1. 36 times 6 is 216. And number 5, hopefully you recalled that those symbols that we see indicate the absolute value. So we'll keep those until the end. We're looking for the absolute value of the opposite of 3 cubed divided by 27. So we have 3 is the base, repeated 3 times. So the opposite of that is negative 27. So we get a negative 1. Remember, absolute value symbols tell you distance from 0. How far away from 0 is negative 1? It is 1 unit. In 6, 9 minus 2 to the 5th power times 0.5. So we'll evaluate the power. And 2 to the 5th power is, 2 repeated 5 times. It's actually 32 times this decimal. So we have to multiply first. 9 minus 16, because 32 times 0.5, or 32 times half, is like 32 divided by 2, or 16. 9 minus 16 is like 9 plus a negative 16, so we actually subtract the two numbers to get 7, and we know that it's negative because the highest absolute value is 16, and it's the negative number. So negative 7 is the final answer there.